Welcome back, year 8s. Another video on factorizing. Before we get started, I know you haven't been at school for a few days, so I was just wondering if you heard about the kidnapping at school. Well, remind me to tell you at the end of this video about the kidnapping at school. Alright, so we're going to get back to factorizing. If you remember, one of our last actual lessons in class, we had been doing things like this. X plus 7 times x minus 7. Right, and we expanded our brackets. We got x squared plus 7x minus 49, which ended up to be x squared minus 49. And I told you to remember this one because this was really important. Well, look at what we're going to factorize. We just need to recognize these. And we should just be able, when we see one, we're just going to know how to factorize it. It's very famous. It's the rock star of factorizing. It's called the difference of two squares. Why is it called that? Well, look at it. It's the difference of two squares. X squared, 49 is 7 squared. So to factorize this, there's not much work we need to do. We just see it. We recognize it's the difference of two squares, and we know how to factorize it. Sometimes we like to write it in a general form. If I have a squared minus b squared, that's the difference of two squares. It will always factorize to a minus b. How did that change in the middle of writing? Times a plus b. Okay, so this is the difference of two squares. It is the rock star of factorizing. You will use it so many times, and a lot of times you're not even going to know you need to use it. So that's the key, is recognizing that. Okay, your turn. Pause the video and factorize this. Okay, we look at this and we should recognize that this is 3 squared minus y squared, which is the difference of two squares. So it's going to be 3 minus y times 3 plus y. That's it. Okay, pause the video. Go ahead and factorize these in your book, and then we'll see how you did. Okay, hopefully you recognize that these are all difference of two squares. So the first one's going to be x minus y. Again, the order doesn't matter. X plus y, the difference of two squares. Remember, 100 is 10 squared. So this should be x minus 10, x plus 10. 49 is 7 squared. So this is going to be 7 minus x times 7 plus x. 1 is 1 squared. So this is x minus 1 times x plus 1. 121 is 11 squared. This is 11 minus y times 11 plus y. 16 is 4 squared. So this is going to be 4 minus z. Ooh, something about that area. Times 4 plus z. The difference of two squares. Looking good. Okay, here we go. Is this a difference of two squares? Again, remember, first let me difference of two squares. It can only be two terms. Remember, we just did a video. We just looked at when there's 4 terms, we use grouping. We'll do a lot more about what to do. There's 3 terms, but for 2 terms, it's usually going to be either just a common factor, like our very first video, or it might be the difference of two squares. So the key is recognizing this. 4x squared is the same thing as 2x squared minus 5 squared. Again, the key on these is going to be recognizing the hidden squares, because 2x times 2x is 4x squared. So once you recognize this, it's going to be 2x minus 5 and 2x plus 5. Again, you can expand the brackets to check to make sure that this works. Okay, pause the video and factorize this one. Okay, did you recognize the difference of two squares? 100 is obviously 110 squared. 81z squared is 9z squared. Notice the brackets. It's not 9z squared. It's not 9z squared. That would not be 81z squared because the squared is only going with the z. So once we got it like that, it's going to be 10 minus 9z and 10 plus 9z. Difference of two squares. Okay, pause the video and factorize these in your book, and then we'll see how you did. Okay, so again, the key is recognizing when they're squares. 16x squared is 4x squared. And 49y squared is 7y squared. So it's the difference of two squares. So it's going to be 4x minus 7y times 4x plus 7y. Again, you can check that. X to the fourth is x squared squared, and a squared b squared is ab squared. So we're going to have x squared minus ab times x squared plus ab. The difference of two squares. X to the fourth we just saw is x squared squared. 4y squared is 2y squared. So this is going to be x squared minus 2y times x squared plus 2y. This is 64 is 8x squared minus 5y squared. So factorize 8x minus 5y times 8x plus 5y. This is going to be x squared squared minus y squared. So it's going to be x squared minus y times x squared plus y. And the last one, this would be in brackets xy squared minus z squared squared. So if I factorize that, I'm going to get xy minus z squared times xy plus z squared. So again, the tricky part sometimes is recognizing when you have a difference of two squares. So that's how to factorize the difference of two squares, the rock star of factorizing. Now, I think I was going to tell you about that kidnapping at school the other day. Don't worry about it. She woke up. Okay, so let's take this one step further now. Is this the difference of two squares? Well, 2 is not a square, and 72 is not a square. So here's the trick. Before we ever factorize anything, you always look for a HCF, a highest common factor. Our most basic factorizing. So if I look at this, do they have a highest common factor? They do. They both have a 2. So this is the same as 2 times x squared minus 36. Now do you see the difference of two squares? Yes, it's x squared minus 6 squared. So this is going to be 2 times x minus 6 times x plus 6. Anytime you're factorizing, always, step number 1, look for a highest common factor first. No matter what, even if you're doing grouping, or when we go to the two brackets, when we have 3 terms, anything, always check for a highest common factor. Okay, pause the video and give this one a go. Okay, if we look at it, we don't see any squares. 27 is not a square, 3 is not a square, but there is a HCF, a highest common factor. They both have a 3. So first factorize 3 times y squared minus 9. Now y squared minus 9 is a difference of two squares. So y squared minus 9 is y minus 3 times y plus 3. We have it factorized. Always look for the highest common factor. Okay, pause the video, do these in your book, and then we'll see how we did. Okay, again, we don't recognize any perfect squares right off the bat. Yeah, I have an x squared, but that's the only thing that's squared. But I can factor out a 2. So this is the same as 2 times x squared minus 4. So this is going to be 2 times x minus 2, x plus 2. Look for the highest common factor. This next one, they both have a factor of 7. So this is 7 times c squared minus d squared. So it's going to be 7 times c minus d, c plus d, the difference of two squares, c squared minus d squared. The next one, they both have a factor of 5. So this is 5 times t squared minus, so we need to work out what 180 divided by 5 is. It happens to be 16. A little hint, we know we're looking for a square. So now I have the difference of two squares. This is going to be t minus 4 times t plus 4. Okay, last example, again, doesn't look like square, but they both have a factor of 3. So this is 3 minus 3 times, brackets 1 minus n squared. Again, 1 is a square. So this is 3 times 1 minus n times 1 plus n. The difference of two squares, the rock star of factorizing.